Today in 7th grade, we're going to be taking a look at misleading graphs, and then we're also going to discuss biased and unbiased sampling or surveying. What is a misleading graph? And here we're going to talk about some of the things that you need to look for to see if a graph could be misleading you in the information that that's given. Here are some things to look for. You want to look to see if an axis is broken, or possibly if there are numbers left out on an axis. Specifically, more often it'll be on the y-axis. Now we're going to take a look at several examples to kind of see what of these ways are shown as to why a graph might be misleading. A second something that you also might look for is the intervals on an axis are not the same length. Now we've talked about what an interval is. And if your intervals are not the same, then obviously your data is not going to be equally represented. Okay, the next one, see if there's different sizes to represent the bars in a bar graph. In other words, does one section look wider than the other? And that might kind of be misleading in its representation. And the last one is, anytime I have pictorial graphs, they could be used to show some distortions. All right, let's take a look at these two graphs. Both of them show the favorite pet survey, dogs, cats, and fish. Now, in this one, it looks like dogs are overwhelmingly the favorite type of pet. But in this one, looks like they're a little more evenly. And these are almost as much as dogs. Okay, take a look at that and see why would they be misleading. Why is one of those maybe more misleading than the other? Okay, so we can show that this one actually is a little bit distorted because the axis is broken here. Or we can say that the pictorial graphs could be distorted, but it's because, in this case, the axis is broken. That's what you would say on this one, that this is showing maybe misleading data because the axis is broken and it makes it look like the dog is so much bigger, when in actuality, when you look at the way your graph is set up here for your axis, it's all even, and therefore they look like there's a few more. They're a little closer than what it does here. Okay, let's take a look at this one. We're going to actually finish up these graphs. Okay, we have Ruby 18. Okay, so we have Ruby types of frog. These are the fastest frogs. Speed got 26, so let's take him up to about here. Okay, Merlin was how much? 16. Okay, it's going to be about down here. Herman is 36. And Molly is 20. And Tex is 28. Now, if we go over here, we're going to plot the same data. Ruby is 18. Merlin is 16. Herman is 36. I'm sorry, Merlin is 6. I'm off here. Ruby is 18. I missed the 26. Okay, so let's fix that. Speed is 26. Merlin is 16. Herman is what? 36. Now we're doing better. And Molly is 20. And Tex is 28. Okay, now showing these, which one is a little misleading and why? Julia? Let's say this is A and this is B. Okay, you're saying A is misleading because of the axis. It didn't start at 0. It started halfway, about up to 15. So really your data over here looks like right here. But in this graph, it makes it look like, hey, they didn't get very far at all. Okay, they're going really, really slow. And that's not the case. All right, Okay, if we look at this one, you notice here lines do help you a little bit to kind of see where exactly your numbers are, but this is showing similar data. This one looks like it really took a big dip and then moved back up. Why? Emma? Because of the broken axis again. Now, is it misleading? Well, a little bit. It's showing a bigger dip. But you know, if I'm a salesperson and I'm wanting to convince you of something, and that's something they do sometimes, is they make breaks in the graphs to try to make the data look like they want it to look in order to persuade you in some way or the other. So you have to be careful. Okay, let's take a look then at this one, the roller skating sales. If you look at this skate, it looks really, really big compared to this skate, correct? But if you look at what amount it's representing, amount is representing 4,800, and this one is almost 2,400, which is half. Does it look like it's half? No, it looks like a lot less. So which example would this be as to why this could be misleading? Because of the pictorial, right? Just your picture itself is causing it to be misleading. All right, let's take a look at this one. Wow, looks like they're steadily increasing. Look at your y-axis here. I'm going up by 5s, but then this one up by 23. And then here I'm only going up by 4, and then here I'm going up by 32. So because your y-axis is not evenly distributed, that data is going to be, or that graph is going to be very misleading. Okay, so now we're going to take a look at samplings of populations. In other words, when you do surveys, we're going to try to use some information to determine if a survey is valid. In other words, is it proper? Could it be used? Is the information valid? It is a valid survey if it's unbiased. Okay, so if you see the term unbiased, that's a good thing. If you see the term valid, that's a good thing. That's what you want your survey to be. You want it to be unbiased and valid. If the data is randomly collected and it represents most all of the desired group, then we can say it is valid. Now, if I say I'm unbiased towards my classroom, that means I usually try to call on boys and girls, and it doesn't matter where you're sitting. I usually try to call on you fairly. Okay, so that's kind of something that you can think about when you're talking about a valid survey. An example of a valid survey would be, let's say I want to find out what people think about our lunch program. If I go and randomly pick every 5th person in the lunch line during all the lunch shifts, could that be a valid survey? It could be, although you have to be careful that you include not only the ones going in line, but if you're surveying just what they think of the food they're eating, then that would be a good survey because those are the ones that are eating it. You don't want to survey people that bring their lunch if you're wanting to find out information about just the ones that go through the line. Okay, so when is it not valid? Not valid, or they call that invalid, or sometimes you might say it's biased. In other words, data cannot, maybe it's not randomly collected, or it's not representative of the entire group. So here are some things you want to look for. Is a convenience survey. In other words, you chose to just survey people close to you in proximity. In other words, instead of going through the lunch line and surveying every 5th person coming through, that I just do your class because I just want to, you're convenient. That would be what I call an invalid or biased survey. It could be where it was voluntary. That, in other words, only those who choose to participate. For instance, let's say that I park myself at a table at the cafeteria. And I say, okay, if you want to tell me what you think of the lunch program, come over here and tell me and fill out your survey. That would be considered invalid because it's voluntary. Probably only those that have problems with the lunch program will come and give you a survey. So you only hear from those that have concerns. And most often, if those that are happy won't bother to come up and fill out your survey. And then the last one, is it biased? In other words, only a select group is surveyed. Maybe I want to know the results, but I only survey boys. Then that would be considered as biased, and it's not valid. So the second part of our lesson today has been about choosing the sampling of your populations, and to do so that your survey is a valid survey. You want to make sure that you get a good representation of the entire group, and that it is not going to be biased by convenience, by just being a voluntary survey, and not just getting a certain select group that you're surveying.